Hi, in the previous videos, we looked at phasors and we have developed the idea of phasors. So, in this video, let's look at um, what happens when you excite a resistor with a phasor voltage. Okay, uh, so uh, think, take a look at this circuit. We are applying a voltage V and a current I flows through resistance, and we know that V is given as Ri. I mean that's you know this, right? So let's say the voltage that you give is a complex exponential signal, Vm e to the power j omega t plus theta, and the current is another complex exponential. Let's just write the amplitude and the phase as different. Okay. And now what we want to do is we want to find out the relationship between this current and this voltage. And of course, the relationship is given as RIM, RI, right? And instead of I, I've just written the complex exponential form of the equation. Now, from this equation, if you remove the j omega t, if you cancel the e to the power j omega t term here and e to the power j omega t term here, what we are left with is Vm e to the power j theta and Im e to the power j phi, which are basically phasors, right? So let's write it in the polar notation and write it as Vm theta and Rim phi. And so what you can see is that how is this phasor voltage related to the phasor current? It's related. R times the current is the phasor voltage. And that's what I've written here. Right? Voltage is equal to Ri. And the same Ohm's law that you know holds for phasors as well. Okay. So another way of saying it is that this equation that we already know, the Ohm's law, is the same when you are writing it for phasors. When you have your voltage and your currents as phasors, you can use the Ohm's law there as well.